Hi guys, sorry for the late upload. I've had some laptop issues. Hope you guys are all doing good. Y'all are safe. I'm going to go ahead and get started with chapter 3, and we're going to start with number 2. So it says 50 individuals are rated on how open-minded they are. The ratings have the values 1, 2, 3, 4, and the corresponding relative frequencies are 0.2, etc. Compute the mean, variance, and standard deviation. So for this one, we are going to go ahead and look at the formulas that are earlier in the chapter, and we're going to go off of those. So we're going to do same thing. We're going to use that x combine to combine the 1, 2, 3, and 4. Okay. So that represents the rating. So they can rate between 1 and 4. And the relative frequencies are the following. So for this one, we're going to do frequencies is equal to combine. We're just going to write the frequencies out, which are 0 0.2, 0, 0.24, 0.4, comma, and 0.16. Oops, sorry. Don't tell me. Number lock. 0.2, 0.24, 0.4, and 0.16. Okay, so those are your relative frequencies of them rating between 1 and 4. Okay, so then we're gonna go ahead and figure out the mean. So the formula for the mean was x bar is equal to the sum of x, which are the ratings, times the frequencies. And that should give you x bar. So now we just write x bar, enter, and it should give you 2.52. Okay, so for the variance, this is bar is equal to, this is also part of the formula, it's in the chapter, kind of just gives you an idea on how to write it out. So we're going to do x, which is what do you call it? The ratings minus the x bar, which is mean, and then we're going to raise that to the second power and times the frequencies, and then this represents the, what do you call it? It says, hold on guys, I'm getting all mixed up. Bar sum x bar frequencies. This is number 2, right? Yeah, because it says 50 individuals, so that is going to be, I think it's 50 divided by, this is just out of the population, this is the sample size. So times 50 divided by 49. Okay, so then now when you put var, enter, and that should give you the variance. And then the formula for the standard deviation is standard deviation, and we're going to use square it here, times the var, which we already have there. And this one should give you the standard deviation. So now we put SD, and that's the standard deviation for this one. The more you guys practice it, the easier it'll be. It's just a matter of kind of learning like the formulas and stuff. I'm going to move on to the next one. So this one says number 4. For a local charity, the donations in dollars received during the last month were 5, 10, 15, 20, 25, and 50, having the frequencies of 20, 30, 10, 40, 50, and 5 respectively. Again, compute the mean, variance, standard deviation. This is just more for practice, guys. So we're going to do the same thing, except that this time it doesn't tell us how like what size of the population it is. So for this one, we're going to do, again, x x equals combine. We're going to take those values, which are 5, 10, 15, 20, 25, and 50. Okay, so this one, since we don't have the sample size, we're just going to put f equals combine. And those are the relative frequencies. So again, 20, 30, 10, 40, 50, and 5. Okay, enter. So now we're going to get that sample size. So it's going to be n equals the sum of those frequencies. We're just going to add that to get the sample size. Okay, so enter. That should already give you the sample size. And now we're just going to do the frequency. So fx, this represents the frequency now. And it's f, which is that the frequency is divided by the sample size. Okay, and now we can do the formula as before. So x bar is equal to the sum, and again x times the frequencies, now that we have the frequencies. Go. So now x bar, and that right there is that mean. So now we're going to do the variance. Okay, so for the variance, again, the same thing as sum of the x minus x bar, which is mean, raised to the second power times the frequencies, and then times, now we're going to do the sample size. So n, we don't have the n minus n1. And that's what it looks like. So you're just basically saying, since we don't know what that sum is, so you're just saying the sample size minus the n minus 1. So it's basically the same thing as this one. So this is 50, and then my n minus 1 is 49. So you're just basically telling them that's the formula there. So bar, enter, should give you the variance. And then lastly, variance. Now the standard deviation, SD is equal to that squared times the variance. Okay, so now we're going to do SD. There you go. That's the standard deviation. Okay, so now I'm going to move on to the next one. For the data in table 2.1, dealing with the changes in cholesterol levels, create a histogram with the R function hist. The data are stored in the file IB table 2, which can be downloaded as described in section 1.5. Based on the histogram, guess about whether there are outliers, and then note that R function outbox finds 2 outliers and outbox pro finds 4. Okay. So for this one, we have to go into that website where all the data are. Okay. So it's the ID table. It's table 2.1. Okay. So I'm just going to go ahead and go to that website and just download it. Okay. And then so now I'm going to go ahead and just retrieve that from the downloads. So I'm going to do CHOL, which is cholesterol levels, equals scan file, and then we're going to do file choose, just so that it opens up that window. And then I'm going to go ahead and look for that in my downloads, and here it is. So now it says read 171 items. Okay. And now that I have that, I'm gonna put hist to make a histogram. Which is the one that we have to save, and then I'm just gonna label, label the okay. So if I go ahead and press X, and this should give you there your histogram. So I just labeled changed cholesterol. This is the frequencies. Okay. So now we're going to do, it says the outline, so we're going to use the outbox and the outpro. So outbox, and we're just going to use tool. Oops. Okay, so I think I don't have the I don't have the ROF thing, so I have to go back and just download that package again, because again it deletes every single time that I open a new one. So I'm just gonna go ahead and do that real quick. Source file.choose. Okay, and I'm going to just do that real quick. Okay. Should be able to do it now. Outbox. See if it works. Yes, there it is. So the out values, there's the two outliers that they were talking about, and then we're gonna do outpro, then control, and it should give you this one. So out values is 4. Okay. So these 4 values here. All right. So moving on to the next one. I'm gonna do number 8, I believe. The height of 30 male Egyptian skulls from 4000 BC are reported by Thompson and Randall Mix. I don't know how to pronounce that. Okay, so then create a histogram with the R function. And it is stored under skull height. And then note that there is no indication of outliers. Verify R function outbox flags 1 value is an outlier, and the MAD median rule applied outbox flags 1 value is an outlier. Okay. Okay, fun story. So for this one again, we're gonna do that. I'm gonna put skull. So scan, like we did before, which was scan file choose. Okay. I think I have to look for it first, and I have to download it first. So it's the skull one. Skull height data, right? Yeah. So I'm gonna go ahead and just go to that website and just right click, save link as. I'm gonna sort it in the downloads, and then I'm gonna go back in here, file.choose. To open up that window for me, and I'm just gonna download that. Okay, so it's 330 items. And now we're gonna go ahead and do the same thing. Okay, so I'm gonna do hist skull, that X label. I'm gonna put skull height. Okay, I'll press enter here, and there is that histogram. And now we're just gonna check for those outliers. So outbox skull. Okay, enter. So that gives you the out values, which is, I guess, just the 1. And now we're going to check the outpro skull. Enter. And 3 are out. Yes. Okay. So now we're going to do number 11. Actually, I think I'll leave that one up to you guys. That one's pretty simple. And that one I think is in page 67. Right, so I'm going to go ahead and move on to chapter 4 now. This chapter was extremely long, but we're going to go ahead and get through it, hopefully. So I think you guys have to do number 9. So for the probability function, it gives you that x, so it gives you 0 and 1, and then it gives you the frequencies, which are 0.7 and 0.3. Verify that the mean and the variance are 0.3 and 21 respectively. What are the probability of getting the value less than mean? Okay, so for this one, give me a second. Okay, so for this one, we're gonna do, do the same thing. So x equals combine, we're gonna do that 0 and 1. Those are the trials that they're giving us. And they're giving us the probabilities, px equals combine, we're doing 0.7, which is related to that 0, which is that end trial, and 0.3. That's the probability of those two. Okay, so enter. To get the mean, we need to do the same, it's the same formula. So sum, we're going to do x times the frequencies, the probability, probabilities. So that should be, that's there the, oh, I'm sorry, I think I'm getting confused. So, yeah. This is a different formula. It's this one. It's we're doing x, which represents the trials, minus that 0.3 raised to the second power times the px probabilities for number 9. Okay, so that's the 21. So that one is fine. And then it's also asking you to do number 10, which is how I got confused. So this one, it says, imagine that an auto manufacturer wants to elevate how potential customers will rate handling for a new car being considered for production. Also suppose that if all potential customers were to rate handling on a 4-point scale, 1 being poor and 4 being excellent, the corresponding probabilities associated with these ratings would be P is 0.2, P2 is 0.4, etc. Determine the population mean, the variance, and standard deviation. Okay, so for this one, again, we're going to take that x equals, these represent the ratings. So they can rate between 1, 2, 3, or 4. So the ratings. Okay, oops, I forgot to combine. So here, just combine. Okay, so then we're going to take the probability. So px equals combine, take all those probabilities. So 0.2, 0.4, 0.3, and 0.1. Okay, so enter. Now for that mean, this is how I got confused. That mean is sum of x times the frequency, times probabilities. Okay, so that gives you the mean. Now the variance, it's this formula. Sum, again, we're we're going to take that x minus that 2.3. 2.3 raised to the second power times the probabilities, px. That should give you 81. And then the standard deviation is just the square root of 81, which is 0.9. Square root. Let's see. Okay, so now moving on to the next one, which is, I believe, number 33. Okay, so number 33. A coin is rigged so that when it is flipped, the probability of a head is 0.7. If the coin is flipped 3 times, with just more likely outcome, exactly 3 heads or 2 heads and a tail. So this one, we're going to use that function, the binom, which is the binary one. I think that one is in page, yeah, it's in page 81. And the functions don't come out until page 85. So it refers to x, size, and the probability. So we're going to take that 2 binom is 2, which represents the 2 heads, and then 3 is the trial, so we're doing it 3 times, flipping it 3 times, and the probability of it being heads or 2 heads is 0.7. Okay, so then we just enter and it should give us a probability of it being heads. So now for the next one of it being, what was it? For it to be 3 heads or 2 tails. Okay, so 3 heads. So we're going to do the same thing, binom. So this one is 3 heads, and we're doing 3 trials. And the probability of that one again is 0.7. Okay, so enter, and that's the probability of it being that one. Okay, so for the next one, I think it's 45. If x is a normal distribution with mean 0.75 and standard deviation is 0.5, use R to determine the following. So this one, 45. Okay, so we're going to use that p-norm function. I don't remember what page that one was. Oh yeah, that one was in page 94. So it says C variable is less or equal to C, and then it's the next one is the mean and then the standard deviation, and it gives us already the mean and standard deviation. So we're going to do 45 p norm, and we're using 45. So the first one is p 0.5 is greater than x, and then less than x and less than 1. So that's just saying that between 0.5 and what are the likelihood that it's going to 0.5 and 1. So for that first one, it is, we're going to take 1, and then it is the formula says, hold on, the mean, which they already give to you, which is at 0.5, so you're going to take 0.75, comma, and then it's the standard deviation. So in this case, standard deviation is 0.5. So 0.5 standard deviation. Okay, So that's the first part of it, and then you're just going to subtract because you're trying to get the probability of between the 0.5 and 1. So we're going to do now P norm, now the other side. So we're doing, it was between 0.5 and 1. So 0.5, and then again the mean, which is 0.5, and then the standard deviation, oh, I'm sorry, 0.75, because we're doing next to mean, and standard deviation is 0.5. Okay, so this is how you get that first one. Enter. Okay, so now the next one, it's saying between 0.25 and 1.25. So again, same thing. So we're doing P norm, but now we want between that 1.25, 1.25, 1.25, the mean is 0.75, and the standard deviation is 0.5. Okay, minus then P norm, and now we're going to do the other one, which is between 0.25, 0.25, and then again the mean is 0.75, and the standard deviation is 0.5. Okay, so that should give you the probability of that one. Okay, and then that's it for that question. And then the last one is 51, I believe. So assume the income of pediatricians is normally distributed with the mean 100,000 and the standard deviation of 10,000. Determine the probability of observing an income between 85 and 115. This is the same thing that we just did here. So we just want to get the probability of them getting paid between 85,000 and 115,000. So for this one, again, we're using that P norm. Now you want to know between 115,000. They give you the mean of 100,000, so 100,000, and the standard deviation is 10,000. Okay, so between this one minus that P norm again, P norm, and now we're going to get the other one, which is 85,000, and again the mean is 100,000, and the standard deviation is 10,000. Okay, and it should give you 0.86%. Okay, so if you guys had any questions about these, you guys can go ahead and email me or text me. I'm going to set up SI meetings on Tuesday and Thursday at 10 a.m. You guys should be able to see that on the Blackboard Collaborative in your virtual meeting space. And usually I'm going to try to go for Fridays to help you guys with the homework. I'm just going to do the same thing. I'm going to record and I'm going to upload it so you guys have like the whole weekend to work on it. Okay, so again, thanks guys for giving me your feedback. Some of you guys said that this really helped, and I hope it keeps helping you guys with this. So hopefully I'll see you soon. Bye.